If you are using STAAD for still design, then definitely you are familiar with the check code command which performs still member design based on user inputs in a non-iterative way. Do you know there is an advanced still design command available in STAAD which can optimize the overall still usage and suggest the most economic section for any member? Hi, my name is Surajit Ghosh, and in this video series, I'll talk about select command, how we can use this command to optimize and reduce still usage of any structure, also the correct sequence to use this along with other commands. In first part, I'll discuss about the basic use of still optimization command with few example models, and in the next part, I'll talk about the design sequence for section selection and use different scenarios to illustrate how to correctly use this command. Before going into the details, just few points about the traditional still design approach. I'll use this model for my discussion. I have created this structure for one of my projects. When we use check code command for still member design using any international code, program designs the member on basis of the design parameter values and critical forces. This is a single step approach and program only reports whether the section pass or fail for the applied loading and design condition. You can go through my previous video on IS800 code part 2 to get a detailed idea about the design philosophy followed in STAAD for any design code. Simply search for the chapter from video description. After design, your job as a design engineer is to review the design results either from the output file or from the post-processing table and take necessary actions. This is the most challenging job. Program can suggest anything, but you have to decide whether it is acceptable and feasible in sight or not. If member fails in design, then you need to increase the section size depending on the failure criteria. Like for bending or interaction failure, you can increase the flange dimension or overall section depth. If member passes, then also you need to check whether the assigned section is properly utilized or not. As you can see here, there are few members for which the utilization ratio is very small, which indicates that the assigned section is heavy for the applied load and not utilized properly. Though this is safe, but it is an uneconomic design. In any of these conditions, you need to manually change the section size, perform design once again, and check the design results to understand whether the current modification provides a more economic design or not. For example, member 25 has a ratio close to 0.2 and assigned section size should be reduced. But what should be the optimum section that you need to find out manually by changing the size? So, you need to repeat this whole process again and again for all members till you find the optimum sections. For a large model, it is really a time-consuming task. There is another design command instead, select command. This command also performs member design but in an iterative way. When you assign select command to a member, program first performs member design on basis of loading, assigned sections and user inputs similar to check code command. But the design process does not end here. In next step, program reviews the utilization ratio. If it is greater than allowable ratio, then program selects another heavier section from the section property table and once again performs the design. If the utilization ratio is very small, then program reduces the section size and selects a light section and redesign to find out the modified ratio. This whole process, design a member, review the ratio, and accordingly select another section and redesign, goes on and on till the ratio is close to 1 or any specific ratio value. This might take few iterations to complete the design process and find the most economic section for a member. There are two outcomes of this iterative approach. Either an optimum section is achieved and program terminates the design loop and reports that particular section. Also, it might happen member fails though the largest section is selected. In such case, failure condition and the last section which was selected for design is reported. You can manually change the shape or go for a composite section. Let's consider this STAAD model again. I have used check code command for member design, and in the utilization table, you can notice several members fail in design check with unity ratio more than 1. Also, there are few members for which ratio is below 0.5. We can easily reduce these sections. If I check the overall steel weight in the output file, it is close to 250 kN. I have used steel takeoff command to print this overall weight of the structure. Next, I have replaced the design command with select command to all these members along with ratio 0.9. Let's check the utilization table once again. There are two sections mentioned for each member. First one is the assigned section and second one is the section which program suggests after iterative selection process. You can notice all ratio values are close to 0.9, which is the allowable ratio for design. Consider member 25, which had a design ratio of 0.2. Now the ratio is 0.8 and suggested section is ISWB 175, which is the most economic section for this member. Similarly, few members were failing, like member 1 and 6. Now those members pass with ratio close to 0.8 with ISHB section. Program internally performs design several times to compute the optimum section for all these members. Isn't it great? If we check the total steel weight now from the output file, it is close to 170 kN. Previously it was 250 kN. So almost 80 kN weight is reduced as the structure is optimized iteratively. That is pretty good for this medium-sized structure. Now, this is not the end. As the section size change, section forces also change, and this structure should be reanalyzed again to consider the modified force values for design. So select command should be followed by reanalysis command, ratio command, and finally a check code command. Why these commands are used and what is the correct sequence, that I will discuss in the next part. Overall, member select command performs a step-by-step iterative design to find out the most economic section and reduce the overall steel weight. Also, it eliminates the tedious manual section selection process. Stay tuned for more updates on steel optimization. And if you like my videos, subscribe and share. Thanks for watching.